Hello everyone. Now let me talk about problem 7 for homework 7. This is the function of zt, and theta is uniformly distributed in 0 to 2 pi. And nt two functions are WSS, well, the three variables are all independent. First, we want to find the expectation of zt. We just put it here, and because they are all independent, we can separate them into this one and this one. We know that the expectation of cosine omega ct plus theta and sine of it are all 0. So the exact result is 0. The second part, find Rz, T1, T2. And we use the same method. We just time the 1, 2, 3, 4. We just time 1 and 3, 2, 1 and 4, 2 and 3, 2 and 4. And we have known that the expectation of cosine times sine and sine times cosine are both 0. So the Rz function gets to something like this. Note that N1t and N2t are WSS, so we can note that the expectation of N1 T1 N1 T2 is just Rn1 T1 minus T2. We can just use this function to express it. And similarly, this. So we also have to introduce the product to some trigonometric identities, which means that cosine A, cosine B is half of cosine A minus 1 plus cosine A plus, A plus B. And sine A, sine B equals to half of cosine A minus B minus cosine A plus B. As theta is uniformly distributed over 0 to 2 pi, we know that the expectation of cosine omega c t1 plus t2 plus 2 theta is 0. So we go back to Rz T1 T2. It is just Rn1 T1 minus T2 times half of the expectation cosine omega c T1 minus T2 plus Rn2 T1 minus T2 times half of expectation of cosine. Now we define tau equals to T1 minus T2. So I say tau is just half of R01 tau plus Rn2 tau times cosine omega c tau. As Rz T1 T2 depends only on the time difference, tau equals to T1 minus T2. The random process Ct is WSS. Then we consider the part C. Find Rz0 if Ct is WSS. So we just let tau equals to 0, and it is and this is 1. So we can just ignore it. And finally, it is just expectation of n1 square plus expectation of n2 square. That's all for this problem. Thank you for your listening.